Hello everyone. Let's discuss today about the basic functionality, the instrumentation and controls involved in industrial centrifuges. Centrifuges are devices basically used to separate heavier particles from the lighter one by the action of centrifugal forces. That's how they are named for. The principal component of a centrifuge is the rotor, which is the moving part that spins at high speeds. They are basically categorized depending on the speeds of rotation. Rotors can be fixed in position, or a centrifuge can use multiple rotors fixed atop part called spindle. The centrifuge works on the principle of increasing effective gravity to enhance the rate of settling of suspended particles more dense than the buffer. We need to double the force on samples, increase the rotation speed by 41%. After centrifuging, the liquid is called supernatant and the solids at the bottom of tube are called pellet. Let's understand the centrifugal force, which is a force arising from the body's inertia, which to act on a body moving on a circular path and is directed away from the center around which the body is moving. So if the internal inside force that is acting is a centripetal force and outside force is a centrifugal force. This is exactly what we have seen in our school days. So it's a process by which a centrifuge is used to separate components of a complex mixture, whether it is a chemical or a solution. By spinning laboratory samples at very high speeds, the components of a given mixture are subjected to centrifugal force, which causes more dense. And the dense particles to migrate away from the axis of rotation and lighter ones move toward it. These particles can sediment at the bottom of the tube, into which is known as a pellet. The remaining solution, the supernatant, can be further processed. So this is a centrifugation of a liquid. If you see the blood sample, separates out blood components by their various densities. The red blood cells are denser and move to the bottom of the tube. The plasma fraction is the least dense, which will float as the top of the layer. You'll see it here. This is the complete blood sample, and the plasma fraction as the latest dense float as a top layer. And we have white blood cells called platelets at the middle, buffy coat, which we normally call, and the bottom we have the red blood cells after centrifugation. This is an armored casing. Before this, you have the thing, and then you will separate out the supernatant and the pellets here by rapidly rotating a rotor. And this is exactly clear. You have a density gradient here, and based on that, you have different components getting separated depending on the centrifugal force. This is a typical laboratory centrifuge, how it looks like. Then we have seen this is a biological centrifugation is a process that uses centrifugal forces to separate the purity of mixture of biological particles in a liquid column. It's a key technique for isolating and analyzing the cells, subcellular fractions, supramolecular complexes, and isolated macromolecules such as proteins and nucleic acid. So this is the basic, we have just seen plasma. If you see 55% of the total blood, less than 1% is buffy coat and 45% is the total red blood cells. So the principle of operation is G is equal to omega square R, which is omega is nothing but radians per second of rotation, and R is the radial distance of particle from the axis of rotation of the centrifuge. And the factors which centrifuges work are more dense biological structure, faster it sediments in centrifugal force, more massive biological particle, faster it moves in the centrifugal field, dense the buffer system, slower the particle moves. These are all the characteristic features. Greater the frictional coefficient, slower a particle will move in that. Greater the centrifugal force, faster particle sediments. Sedimentation rate of a given particle will be 0 when density of particle and the surrounding medium are equal. So these are all the different factors on which the centrifugation will be operating. Then if you see the separation by sedimentation, then we have the sedimentation, the higher the density at the bottom. You have the material iron of 100 kg, iron of 10 kg, and iron of 1 kg, you will see, which will get separated, sedimented at the bottom. Then we have stones of 30 kg and 10 kg in the next layer, although their configuration and shape is different. And then finally, cotton, which is floating at the top. So this is how separation is done by sedimentation. The sedimentation time depends on size of the particle, density difference between particle and medium, radial distance from axis of rotation to liquid meniscus, we normally call it as RT, and radial distance from the axis of rotation to the bottom of the tube. That's what we normally call it as RB. So there are different types of centrifuges, desktop centrifuges, high-speed centrifuges. Ultra centrifuges are categorized both for analytical purpose and preparative purposes. So a desktop centrifuge is very simple and small, maximum speed 3000 RPM. They do not have any temperature regulatory system. They are used normally to connect rapidly sedimenting substances such as blood cells, yeast cells, or bulky precipitates of chemical reactions in chemical industry or a petrochemical industry. Then high-speed centrifuges are, of the ranges 25,000 RPM, providing 90,000 G centrifugal forces. G we have seen just R square omega. Equipped with refrigeration to remove heat generated and temperature maintained at 0 to 4 degrees centigrade by means of thermocouple. And all these features are available in high-speed centrifuges. If you see the ultra centrifuges, they operate at more than 75,000 RPM, providing 5 lakhs of G. And rotor chamber is sealed and evacuated by a pump to attain vacuum. This is exactly how it is. And then again, refrigeration is available at 0 to 4 degrees centigrade. And centrifugation for isolation and purification of components is known as preparatory centrifugation, whereas characterization is known as analytical centrifugation. That's how, for the two reasons why ultracentrifuges are used. And if you see the instrumentation part of it, the basic centrifuge consists of mainly two components: electric motor with drive shaft to spin the sample, and then a rotor to hold the tubes or other containers of the sample. And instrumentation also include a power switch which allows the current supply, where you can have the current control for this, for speed control. Then a timer which allows a rotor to reach a pre-programmed speed under optimized conditions, and then decelerate or retard without braking after the set time. Speed control is always by a potentiometer which changes the voltage supplied to the motor, and you always have a tachometer which indicates the speed of the rotor, RPM. So brake operates by reversing the polarity of the current to the motor. This is the basic instrumentation available, and all the centrifuges are highly automated. And this is another thing where you have a feed flow rate coming through this, and solid ejections are taking place. Concentrate solid stream is going in here, where you have a control valve, and concentrate is going through a turbidity meter here. And this is how the another type of a centrifugation which is happening here. And this is the final control, where the speed, everything, you have a control drive panel here, which is giving power to your actuator control, your centrifuge operating panel, and from power supply, you are getting the power. Okay, so this power you are giving basically to the control point here. And here the speed is the entire data of the thing through wireless. It is acquired by a data acquisition system. And here you are a bidirectional signal from and to the actuator, and again bidirectional signal from to and from the control drive. And you are getting through actuator, you are giving a power, where this makes the centrifuge totally automatic. Okay, and this is how basically the centrifuge is always pre-programmed for certain speeds, for certain operations, whether they are biological samples or chemical samples. And this is the total instrumentation and control of a typical industrial centrifuges.